Right now, at this exact moment, two machines built nearly half a century ago are traveling through interstellar space. Not one. Two. Subscribe my channel for more videos. Most people know Voyager 1, the farthest human-made object ever sent into space. The spacecraft that crossed the heliopause in 2012 and became the first human-built machine to enter interstellar space. The one carrying the golden record. The one that continues to make headlines because it refuses to disappear. But there is another spacecraft out there. Quieter. Less celebrated. Often overlooked. Voyager 2 is moving through the darkness billions of miles from Earth, traveling through a different region of interstellar space and carrying something its twin lost decades before reaching the edge of the Sun's influence. An instrument capable of directly measuring plasma. And that difference turned out to be enormously important. Because when Voyager 2 crossed the heliopause in November 2018, it gave scientists something Voyager 1 could not provide: direct measurements of the plasma surrounding the boundary between the solar system and interstellar space. The result did not simply confirm what Voyager 1 had discovered. It complicated the picture. It revealed that the boundary between the Sun's influence and the space between stars is far stranger and more dynamic than scientists once imagined. And now, nearly 50 years after launch, Voyager 2 faces another challenge. Its power supply is slowly disappearing. The spacecraft is still functioning because of the gradual radioactive decay of plutonium inside its radioisotope generators. But every year, the available electrical power decreases. Engineers have spent years finding ways to shut down unnecessary systems, redirect power, and keep the remaining scientific instruments alive. Because once Voyager 2 goes silent, there is no replacement waiting nearby. There is no second spacecraft currently sitting at the edge of interstellar space ready to take over. For the foreseeable future, these two aging probes are our only direct observers in that distant environment. Voyager 2 began its journey on August 20, 1977, just 16 days before Voyager 1. The numbering can be confusing, because Voyager 2 actually launched first. The names reflected the order in which the spacecraft were expected to encounter their primary targets. Voyager 1 was placed on a faster trajectory. Its path would take it past Jupiter and Saturn before sending it northward and eventually outward toward interstellar space. Voyager 2 followed a much more ambitious route. Its trajectory was designed to take advantage of a rare planetary alignment that allowed a spacecraft to use the gravity of one giant planet to reach the next. Jupiter, Saturn, Uranus, Neptune. It was an opportunity that would not repeat for generations. And Voyager 2 took advantage of it. That decision created one of the greatest journeys in the history of space exploration. Voyager 1 visited Jupiter and Saturn before continuing outward. Voyager 2 visited all four giant planets: Jupiter, Saturn, Uranus, and Neptune. No other spacecraft has ever completed that journey. And every encounter changed what scientists thought they knew about the outer solar system. At Jupiter, the spacecraft encountered an atmosphere that was anything but calm. The giant planet's cloud bands were filled with enormous storms and rapidly changing structures. The Great Red Spot became more than a distant feature seen through telescopes. Voyager revealed it as a massive atmospheric system embedded within a planet whose atmosphere was constantly moving and changing. But Jupiter itself was only the beginning. One of the greatest surprises came from Io. Before Voyager, there was little reason to expect Io to be one of the most geologically active bodies in the solar system. Scientists expected an ancient, heavily cratered world. Instead, Voyager saw volcanoes. Not ancient volcanoes. Active ones. Plumes of material were rising hundreds of kilometers above the surface. Lava was flowing across a world whose interior was being intensely heated by gravitational interactions with Jupiter and the other Galilean moons. Io was not a dead satellite. It was a world in the middle of an ongoing geological catastrophe. Then came Europa. Its surface was covered in enormous fractures and strange patterns unlike the heavily cratered landscapes scientists expected from an icy moon. Those observations helped establish Europa as one of the most intriguing places in the solar system. Beneath its frozen surface may lie a global ocean of liquid water. Voyager did not prove that ocean directly, but it gave scientists the first major clues that Europa might be far more active and complicated than its frozen exterior suggested. The message was becoming impossible to ignore. The outer solar system was not a collection of frozen, inactive worlds. It was alive with geological activity, chemistry, weather, magnetic fields, and hidden processes. Then Voyager reached Saturn. From Earth, Saturn had always looked almost perfect. A beautiful planet surrounded by elegant rings. But Voyager revealed that the rings were vastly more complicated than they appeared through Earth-based telescopes. Instead of a handful of smooth bands, scientists found countless ringlets, gaps, waves, structures, and intricate patterns shaped by gravity. Small moons acted as shepherds, helping confine narrow rings. Other moons interacted with the ring material in ways that produced patterns nobody could have seen from Earth. Saturn's rings were not simple decorations. They were an enormous dynamical system. And then there were the moons. Titan immediately became one of the most important targets in the solar system because of its thick atmosphere, dominated by nitrogen. It was a world unlike almost anything else known at the time. Voyager also observed Enceladus, another moon that would eventually become famous for its geological activity and evidence of material escaping from beneath its icy surface. The deeper the spacecraft traveled, the more obvious the pattern became. The moons were not secondary objects. They were worlds. Worlds with atmospheres. Worlds with oceans. Worlds with volcanoes. Worlds with fractures, weather, chemistry, and histories that could rival those of planets. After Saturn, Voyager 1 continued outward. Voyager 2 kept going. Its next destination was Uranus. When Voyager 2 arrived in 1986, Uranus looked almost disappointingly calm. Its atmosphere appeared smooth and featureless compared with Jupiter and Saturn. But Uranus was hiding something extraordinary. The entire planet is tilted dramatically on its side. Its rotational axis is inclined by roughly 98 degrees. Its magnetic field is also unusually tilted and offset from the planet's center. Voyager discovered new moons and new rings, and it found that several of Uranus's moons were geologically far more complicated than expected. Then there was Miranda. At first glance, Miranda looked almost impossible. Its surface appeared to contain enormous cliffs, grooves, fractures, and contrasting geological regions that made the moon seem as though it had been broken apart and assembled again. Whatever happened there, it showed that even a relatively small icy moon could possess a complicated geological history. But Voyager 2 was not finished. 3 years later, it reached Neptune. This was the final planetary encounter of the original Voyager Grand Tour. And once again, the spacecraft found a world that refused to match expectations. Neptune's atmosphere was moving at astonishing speeds. Storm systems appeared and disappeared. The planet possessed powerful winds and a dynamic atmosphere despite receiving only a tiny fraction of the sunlight Earth receives. Voyager also examined Neptune's rings and discovered structures that were far more complex than expected. Then came Triton. Triton looked frozen. but it was not completely inactive. Voyager observed dark plumes rising from its surface, revealing that even this extremely cold moon could possess active processes. The spacecraft had reached the final planet of the Grand Tour, but the discoveries were not ending. They were changing the questions scientists were asking. What Voyager revealed was that the outer solar system was not a simple collection of planets and moons. It was a network of interacting worlds. And some of those worlds might contain environments capable of supporting conditions suitable for life. Then Voyager did something even more powerful. It looked back. Far beyond the planets, Voyager 1 turned its camera toward Earth and captured a tiny point of light suspended in a beam of sunlight. Earth.